Okay, welcome back everybody. We're going to take a look at this problem. So again, remains the same. If two things remain... Are you guys all here?
Professor is muted.
Oh, thank you. All right, can you guys hear me now? Thank you.
Yes.
Okay, good. Thanks. All right, so welcome back. And here we're saying they remain the same. So if these two things, before and after, remain the same, that means that they are they less than, greater than, not equal to, or equal? What are they? Before and after. Well, they remain the same. If they're the same, then what are they? They're equal. Does that, you guys follow what I'm saying? So if they remain the same, then they're equal. So here we're saying that before and after remain the same, so they're equal to each other. So our claim is that mu1 equals mu2. What that means when we translate it into this, this dependent, two-sample dependent thing, because the two-sample dependence, we take the first one, we subtract the second one. So if they're equal, if we take the first one, subtract the second one, we're going to get 0. Because if these two are the same, then when you subtract them, they'll equal 0. So that's my claim, is that mu1 minus mu2 equals 0. In other words, mu d, because remember mu d is mu1 minus mu2, is equal to 0. That's my claim. My claim is that mu1 minus mu2 equals 0, so mu d equals 0. That's my claim, which means that I use the word reject now for step 5. Because rejecting H naught rejects my claim, because they're together. If H naught is, if my claim is H naught, then H1 becomes the opposite of H naught, so the opposite of equals is not equal to. Remember, the numbers stay the same, it's the symbols that change. So mu1 minus mu2 is not equal to 0, or in other words, mu d is not equal to 0. That's my step 1. Step 2, critical value. All right, two tails. It's a mean, so we care about degrees of freedom. I have 6 items, so degrees of freedom is going to be 5. So if I bust out my little t-table, alpha is 0.05, alpha is 0.05 two-tailed. So 0.05 two-tailed, and degrees of freedom 5, 2.571. There's my critical value right there. So positive, negative, 2.571, so there'll be the negative 1 shade to the left, the positive 1 shade to the right. And then we're going to find our test stat. So you're going to subtract these and find their differences. Or you can use your calculator, or you can just subtract them. Either one's fine. And then put these into your calculator and do stat calc 1 bar stats on them to get your x bar, which is 16.7, and your s, which is 25.4. And why do we round to 1 decimal place? Because our data has no decimal places. Remember, the mean and standard deviation, you always want to round to 1 more than your actual data is in. So since these have no decimal places, we're rounding to 1. On your quiz problems had 2 decimal places. So then you'd be rounding, we rounded those to 3 decimal places, because again, 1 more than your actual data is in. All right, but again, that's not as big a deal. I'm not going to worry about that as much since we haven't even had our chapter 3 exam yet. So as long as you do 3 sig figs at least, then I'm going to be fine. It's not going to be that big a deal. All right, so here, test stat is our x bar, 16.7 minus our mu from our claim, so that's 0, right, over our s over square root of n. We have 6 items, and it's 6. We get 1.61. That goes in here, completely in the do not reject range, right, the not guilty range, not enough evidence, so we do not reject H naught, which means that since we did not reject H naught, we do not have enough evidence to, and here's the thing, since H naught is my claim, I'm going to use the word reject here. Not enough evidence to reject the claim that cholesterol levels remain the same. All right, so here, I'm doing this, if I get something out here and these edges out here, way out here, or way out here, and I say, oh, I'm way out here, I would reject the claim that they're the same and say they're not the same. So that's why we use the word reject there, because what happens if we get something out in this area? If we get something out in this area, that rejects our claim. Since our claim is that they're the same. Our claim is that they're the same. Our claim is that they're right here. If I get something in this range, I say, okay, my claim might be correct, maybe. But if I get something out here, my claim is not right. I'm going to reject my claim. So that's where those words come from. All right, questions about this one? Anyone? Anyone? All right. So we will go ahead and move on. Don't worry about that. That's not very interesting. All right, so now we're going to look at proportions versus means. We're getting into our review. We're going to do a little bit of review, and then we'll do a few problems, and then we'll go. Okay, so a proportion. How do you know it's a proportion versus a mean? A proportion will have an experiment or survey where the answers are yes, no's, or are, aren't, not numbers. It looks like either, it'll either be a percentage, or it'll be a fraction, or it'll be a fraction in disguise. But more importantly, nowhere are the words mean or average. A mean will always have the word mean or average, or X bar, which is another word for mean, right? This is a symbol for mean. Or it might be a mean in disguise, which is I give you a list of data that are numbers. When your data is numbers, then that's a mean because I'm saying you find the mean yourself. Here's a bunch of numbers, you find the mean, so that's kind of a mean in disguise. It kind of all comes down to what you're asking in the survey. Not what I'm asking you, but what the original person asked the people in the survey. If they said, what's your height? Right? What's your height? That's your number is going to be a number. Your answer is going to be a number, so that's going to be a mean. Are you an English major? The answer is going to be a yes/no answer, so that's going to be a proportion. How many siblings do you have? That is not a yes/no question. How many siblings do you have? You're going to answer a number. So again, that is numerical, that's a mean. On exams, I expect you to do these steps. Step 1, state your H0 and H1. Step 2, find your critical value. Oh, and also on step 1, also tell me which one's the claim. That would help me out. Step 2, find your critical value from the table and draw a picture. Don't forget your Z table is the bottom row of your T table. So your T table is really your Z and T table combined. Step 3, find your test stat, your test value. Test stat is another word for test value. Write your formula including the numbers inside of them. And then decide to either reject or not reject H0. And then last, summarize the results for your claim. All right, so the other thing you're going to want to know is this a confidence interval or a hypothesis test? So here's the deal. In your exam, you are going to have 8 problems, only 8 problems. You're going to have one each of the following. For confidence intervals, chapter 7, you're going to have one confidence interval for a proportion, one confidence interval for a mean. And then you're also going to have a find n problem, right? So it's a confidence interval that has a question with it, finding n. So it's a little bit different. It's a confidence interval, but it's a subset. It's the how large of a sample size do I need? Then you're going to have, from chapter 8, you're going to have 2 problems from there, a confidence interval for a proportion, and a confidence interval for a mean. And then for chapter 9, you're going to have 3 problems. You're going to have a 2-sample proportion test. You're going to have a 2-sample mean independent test, and a 2-sample mean dependent test, which is the one we've been working on today. And we'll talk a little bit more about how to tell those apart in a minute. But it's really important that you be able to tell apart the difference between a mean and proportion, between a confidence interval and a hypothesis test, between 1 sample and 2 samples, and also between independent and dependent. But the main things are these 3 questions. Is it a mean or a proportion, confidence interval, hypothesis test, 1 sample or 2 samples? Yes. The exam is only 8 problems. That means if you screw up a problem, that's like 12 points of your test. That drops you a whole grade. So the issue with that is it's really important. If you do the right, if you do anything kind of correctly, but for the wrong problem. So in other words, you find the error correctly and you use the correct critical value and you find a confidence interval, but I've asked you for a hypothesis test, you're going to lose like 8 points on that one problem, which is almost a whole grade. So it's really, really important that you identify the problems correctly, and if you're supposed to do a confidence interval, then you don't do a hypothesis test or vice versa. Right? And these are things that people screw up over and over again, which is why I've emphasized them today, because I want to make sure that very few people make these errors. So confidence interval will always say estimate or confidence interval, always. So if it says estimate or confidence interval, it's a confidence interval. If it doesn't, it's almost definitely a hypothesis test. Yeah, I would say it is. It's a hypothesis test. So if it says estimate or confidence interval, it's a confidence interval. If it doesn't, it's a hypothesis test. Also, hypothesis tests will have words like claim, test, and conclude. Okay, so that's kind of how you tell them apart. One sample or two samples, find the actual word sample or selected or surveyed. There's kind of, other words for sample. And see how many groups were actually sampled. So it's kind of the way of doing it. Your sample has to have a sample size. If it doesn't have an N, it's not a sample. And the last thing I wanted to go over to before we get into kind of reviewing problems was this review of confidence intervals, because it's been a while, right? So step 0, first find your best point estimate. You guys are going to screw this up. Some of you guys are going to screw this up in about 10 minutes or 15 minutes, 20 minutes. So step 0, find your best point estimate. That point means one number. So find your best point estimate means, say I have, I'll stop sharing for a second. All right, so say I want to know the average height of all men in the United States. So I take a sample of men in the United States and I find their average. And say their average is 67.4 inches. Then my best one number guess at the true average of all of the men in the United States would be 67.4 inches, whatever I got from my sample, my X bar. So your X bar is your best one number guess, right? So that's your best point estimate. That's what a point estimate is. It's your best one number guess. So it's going to be your X bar or your p hat. That's your best one number guess. Step 2, find the critical value. Look it up on the t-table or the z-table, depending on whether it's a mean Mr. T, t-table, easy peasy, p, proportion, z-table. And then step 2, find your margin of error E. So that's the amount you're going to add or subtract from your X bar or p hat to get to your confidence interval. So that is your critical value. It says this, but really, if you look at your notes, right, it's here on your magic formula sheet. It's right here under error right here, or error right there. They call it a T alpha over 2 or Z alpha over 2. Really, that's just critical value. And you can write in, I'm fine with you just writing in right on that top of that, CV instead, because that's what we've been used to calling them. So that kind of makes more sense, I think, for folks. So you can just, instead you just write CV right on top of that, because that's really your critical value that you look up in your table that you found up here, multiplied by, for a proportion, multiplied by square root of p hat q hat over n, or for a mean, multiplied by s over square root of n. And then step 3, find the actual calculate the actual interval. So that's p hat plus or minus e for a proportion, or x bar plus or minus e for a mean. And then step 4, draw a picture. So you're going to draw your little normal curve, and you're going to shade both ends, and you're going to put in whatever values you got from your confidence interval into here, your lower limit and your upper limit into there. So those are kind of your steps for confidence intervals. Any questions on that one before we move on? Oops. Chat. Okay, I guess not. All right. So again, back to this important question of making sure that you can identify the question properly and you don't lose half your points on the exam by not being able to figure out what type of problem it is. So right now, I do not want you to solve these. I just want you to identify the type of problem, mean or proportion, T versus Z, or test versus confidence interval. And so let me get someone to go ahead and read this first one here. Laurel, why don't you go and read starting from a medical investigation?
Medical investigation claims that the average number of admissions per week at a hospital in southwestern Pennsylvania is 16.3. A random sample of 10 weeks had a mean number of 7.7 infections. The sample standard deviation is 1.8. Is there enough evidence to reject investigative claims at alpha equals 0.05?
Great, that's good, thank you. All right, so you guys take 15 seconds, figure out whether it's a mean or proportion problem, whether it's a T-table or Z-table you're going to use, and whether it's a hypothesis test or a confidence interval. Go, 15 seconds. Okay, is this a mean or a proportion, guys? Which one is it? Yep, mean, good. It says average, so it's a mean. So is this going to be a T-table or a Z-table we're going to use?
T-table.
Right, mean Mr. T, right? Mean Mr. T, we're going to use the T-table. Is it a hypothesis test or a confidence interval? So look and see if you can find the word estimate or the phrase confidence interval in here. Do you see estimate or confidence interval here anywhere? I don't see it, so it's a hypothesis test. Yeah, because it doesn't have confidence interval or estimate anywhere, so it's a hypothesis test. Also, it has words like evidence, reject, and claim, right? Claims. So those are good hints that it's a hypothesis test. All right, Rosa. My bad. Rosa, go ahead and read this one.
Sorry, had to unmute.
That's okay.
Fruit consumption. A nutritionist found that in a random sample of 80 families, 25% indicated that they ate fruit at least 3 times a week. Find the 99% confidence interval of the true proportion of families who said that they eat fruit at least 3 times a week.
Great. All right, everybody, 15 seconds. Mean or proportion, Z-table or T-table, hypothesis test or confidence interval. Go. All right. Is this a mean or a proportion? Proportion. How do you know? There's no word mean or average here. Also, it literally says proportion. And you've got percentages here. Good. So is this a T-table or a Z-table? Easy peasy, so proportion, Z-table. Is it a hypothesis test or a confidence interval? Do you guys see the word estimate there anywhere, or the phrase confidence interval anywhere?
Yes.
Yes. Confidence interval, right there. So it is a confidence interval problem because it says find the confidence interval. So again, remember, if you, this is really annoying, sorry, hold on. So if you see the words confidence interval, then it is a confidence interval. Good, so again, proportion, easy peasy means it's a proportion Z-table, and then confidence interval, because it literally says confidence interval. Great. Next, Angela, go ahead and read this one.
150. The variable is normally distributed and the population standard deviation is 100. The same superintendent in the previous example wishes to see if her students scored significantly below the national average on the test. She randomly selected 36 students, or 36 scores as shown. At output point 10, is there enough evidence to support this claim?
Okay, 15 seconds. Go ahead. Mean or proportion, Z or T, hypothesis test or confidence interval. All right, is this a mean or proportion, guys? Mean, it says average. All right, so people are picking up on that one. Also, my data is numbers, right? Your data is numbers, it has to be a mean. All right, so is it Z or T? Mean, Mr. T, yep, so T table, great. And is it a hypothesis test or confidence interval? Yep, hypothesis test. Because nowhere is the word estimate or confidence interval anywhere. And also there's about things about evidence and claim, so those will only go with hypothesis tests. Okay, so good. Soraya, go ahead.
According to a professional school company, an unbelievable low percentage, 36% of all Americans said that they were fans of professional baseball. A random sample of 200 people indicated that 88 were baseball fans. At alpha 0.01 is the proportion greater than 36%.
Great. All right, so 15 seconds. Okay, is this a mean or proportion? Proportion, it says proportion. Great. Also, no word mean or average anywhere. Is it a Z table or a T table?
Z table?
Yep, Z, easy peasy. So Z table. And then, is this a hypothesis or a confidence interval?
Hypothesis.
Yeah, so this one's a hypothesis test. Why? Because there's no word estimate or confidence interval anywhere. They're not there. If you look for the word estimate, it's not there. If you look for the word confidence interval, it's not there. So it is a hypothesis test. Good. And here's the thing: is the proportion greater than? So it's asking. Here's the question: is it greater than? The other thing is that hypothesis tests will always have a question. Whereas confidence intervals, general confidence interval will not have a question. The only thing that will have a question is that subset under confidence intervals of the find n. It might say, if you have to find the sample size, if find n, then that would be the question. So if it's a confidence interval with a question, then it's a find n problem. Otherwise, all other question ones will be hypothesis tests. So if it says confidence interval and there's a question, it's a find n problem. If it doesn't say confidence interval or estimate, then it's a hypothesis test and it should have a question. Austin, go ahead.
Assuming that we want to estimate the mean IQ score for the population of students, how many statistics means once you randomly select for IQ test want a 95% confidence that the sample mean within the IQ point population?
Great. All right, 15 seconds, everybody go. Okay? So yes, you guys correctly said it's a mean, totally, which means it's a t-table, mean Mr. T, and it is an estimate, so it's a confidence interval, right? However, there's a question. So it's an estimate with a question, which means it's that special kind. My question is this: how many students must be randomly selected if we want to be, 95% confident that the sample mean is within 3 I2 points of the population mean? So this is a how many students? How many students? How big should my n be? This is a find n problem. All right, so when you have a confidence interval estimate with a question, that is almost certainly a find n problem. So here, I need to find n, which means I have to give you the error. You can't find n without the error. You need to have everything else, right? I can only be holding one thing back from you. So if I'm asking you to find n, you have to have everything else. You have to be able to figure out the critical value from the confidence level. You have to be able to know what the E is. And okay, and you'll have to have other information. So this is a find n problem. Everybody good with that part? And then we're going to do this one. Rizzo, go ahead.
A researcher wishes to test the claim that the average cost of tuition and fees at a 4-year public college is greater than $5,700. She selects a random sample of 36 4-year public colleges and finds the mean to be 5950. The population standard deviation is 659. Is there evidence to support the claim at alpha 0.05?
Wait, 10 seconds, everybody go. Okay, so, yeah, so average, so it's mean, so it means it's a t-distribution, and it's a hypothesis test, because, again, there is no word estimate or confidence interval here anywhere. So without the word estimate or confidence interval, it must be a hypothesis test. And also you have evidence to support the claim, so these are all hypothesis test words. Okay, this one's a little bit, all right, so I'm just going to talk about the part that's important. So construct a 95% confidence interval estimate for the differences between the mean creativity score for those with a red background and the mean creativity score for those with a blue background. Here's my information here. 10 seconds, go ahead. Okay, guys, this is a mean or a proportion? You guys are so confused about this one. Okay, not yet. So it's, see the word mean here? It's a mean. Also, see this little X bar right here, too? X bar? That also means X bar is not X, but X bar. That's a mean. So this is a mean, which means t-distribution. And it's going to be a confidence interval. I think you guys picked up on that one. And it says estimate also, it says both. So yeah, confidence interval, totally confidence interval. Here's the deal. This is 2 samples. Do you guys see how there's 2 samples here? So it's 2 sample mean. Is it independent or dependent? That's the good question. So this is the other tough question. And this is the kind of question that'll lose a lot of people 7 or 8 points. Independent or dependent? So So the question is, do you have two sets of numbers that are matched up in pairs with each other? Do you have two numbers that go hand in hand with each other all the way? They're identical. Do you have something like this, where they're all matched up like that? Or do you have just two numbers sitting out there? We just have the data. You did not get numbers going that are one-on-one matched up with each other. So these are independent. That's how you can tell, is that they're just numbers that are sitting out there that are not matched up with each other. So it could either be where I don't even give you the data. You're given no data. If you're not given data, it can't be dependent because you have to subtract each one of those little pieces. So if you are not given data that's matched up, like for instance, these guys are matched up, right? They're all matched up. If you're not given data that's all matched up like that, then it has to be independent. Okay, so this is a two-sample independent one, which means that when you get the sheet, you're going to be using this one right here, independent. Why? Because the one that's dependent, you're going to take those two dependent ones that are set together, and you're going to subtract them so that you only have one. So then you're going to treat it like a one sample t-test. Because after you subtract them, you're going to be left with one set of numbers. Okay, good. Haley, go ahead and read.
The Gallup crime survey stated that 23% of gun owners are women. A researcher believes that in the area where he lives, the percentage is less than 23%. He randomly selects a sample of 100 gun owners and finds that 11% of the gun owners are women. At alpha equals 0.01, the percentage of female gun owners in his area is less than 23%.
All right, 10 seconds, guys. Take a look. All right, proportion or mean? Yep, proportion, there's no word mean or average. Also, there's a percentage, which is just like a proportion. There's also a percentage here that's not my alpha. Okay, good. Now, okay, so Z table, you guys got that right, and then it's a hypothesis test because nowhere in here is the word confidence interval or estimate. And also, this is a question. This is actually a type, but it should have been a question mark. Right, is the percentage. So that's a question. So this is totally a oops, my bad. This is totally a hypothesis test. All right, next one. Eduardo? Actually, don't worry about this one. This one, the thing I want to point out with this one more than anything else was I want to ask you guys how many samples this is. So go ahead and read it for yourselves. Take 20 seconds since you're going to read it for yourselves. Mean or proportion, Z or T, test or confidence interval, and how many samples are there. So 20 seconds. I should mute myself because it's stupid train. Okay, good. Mean, average, mean Mr. T, it's T. I say confidence interval because it literally says confidence interval. Please note, there is only one sample. A lot of times when there gets to be a lot of words, people get freaked out and start thinking that there's two samples. So find the word sample, and then you should find your N really close to it, sample of N. and then you have your sample mean and your sample standard deviation. This over here does not have an n. It doesn't have a sample size. You can't have a sample without a sample size. So unless it has an n and a mean and a standard deviation, it is not, or at least an n, right? Your proportion will have at least an n. You cannot have a sample. So this is not the sample, this is your mu. Right, so this is how you know this is the mu, because it doesn't have a sample size with it. So a lot of people get screwed up on that one. That's why we're pointing this one out. And that's okay. And that one's, this one's 2 samples. All right, so you guys, this one, is it a proportion or a mean? Proportion, yep. So it's going to be a Z distribution, and it is a confidence interval. Good. You guys see the confidence interval part here? So that's how you know it's a confidence interval. And also you have a percentage here, and no, and again, no mean or average. This one, take a look and look through it and try to figure out mean and proportion, hypothesis test or confidence interval, and how many samples. All right. So again, yep, it's a mean average, which means it's the t-distribution. It's a hypothesis test because there's no word confidence interval or estimate in here anywhere. And then also it says concluded. How many samples is it? 2 samples, yep. So it's a sample of with an n and a mean and a standard deviation and an s. And there's another sample with an n and a mean and an s. So that's 2 samples with each with their own n. Right, so there's a sample here, there's another sample here, this is males, that's females. This is a 2-sample mean. Is it independent or dependent? What do you guys think? Independent or dependent? This is important. Only 3 people know? Anybody else know? This is probably the #1 loser of like 7 or 8 points on the exam that people have. I have on average, gosh, like 25% of the class usually misses this. Okay, yep, it's independent because you do not have them side by side. You just have the numbers. If I just give you the numbers, here's the mean, here's the standard deviation, then it's independent. To be dependent, again, I have to give you 2 lists of numbers that match up, and they're all matched pairs. You guys are okay with this one. This one is, what do you guys think about this one? Is it a proportion or a mean? 17%, it's a mean, proportion, sorry. So it's Z. And again, no confidence interval or estimate, so this is going to be a hypothesis test. Evidence to reject the claim. It's a question. Okay, this is the last one I wanted you guys to take a look at. I'm actually going to read it. Oh, okay, you guys are working on it. That's fine. Go ahead and take 20 seconds. And is there anything special about this one? Anything special about this one? sorry, my bad. Okay. Right, so it's a proportion, right? So it's a z distribution, and it's a confidence interval because it says estimate. You guys see where it says estimate? So that means it's a confidence interval. However, there's a question. So a lot of you guys pointed out, it's a find n problem. Find the sample necessary. How large should the sample be? So here, just to give you guys a little review on this one, we're going to look at the second part. If no estimate of the sample proportion is available, how large should the sample be? We're going to answer this yellow one, orange one down here. So first, I have to give you the E. If I'm asking you to find n, I must give you E. So here, find the word within, or find the word error, and you'll find your E. Everybody find the word within here? Find the word within. Where's within? Yep, right here, within 4%. So that's my error. So that means my error is 4%, 0.04. I don't have any estimate of the sample proportion, so I'm going to have to use 50-50 for P and Q, 0.5 and 0.5. 95% confidence, and it is a proportion, so I can look that up, two-tailed, 95%. It's going to be 1.96 for my critical value. So then I throw them into my handy-dandy formula sheet, and it says, if I look here, this one's a little bit wiggy, but it says that minimum sample size P hat Q hat times Z alpha over 2 over E squared. You can make that Z alpha over 2 into critical value. So critical value over E squared, and multiply that by P hat and Q hat. So critical value over E squared multiplied by P hat Q hat, 1.96 over 0.04 squared times 0.5 times 0.5, and then make sure you round up to the next whole number because this is the minimum you need. You have to round up because you can't sample a portion of a person, and that's, so you always round up. Alright, so now we're going to do a couple problems. You're supposed to bring a blank sheet of paper today, so we're going to do 2 problems, and then we'll call it quits. We'll probably end a few minutes, or maybe 5 minutes early. So here's the first problem. Go ahead and write it down as you like, and then whenever you're ready, hop into your groups. You don't need to write down the whole problem. I just need, so on your paper you're going to put in number 1, and just, you know, the stuff you need from here, and then go solve it. And then you're going to turn in problems number 1 and number 2 on this sheet of paper. This is what you're turning in today for your classwork. So number 1 for this one, and then whatever information you absolutely need for this, and then you're solving your problem solving for this one. So I'm going to go and open up your breakout rooms whenever you're ready to go in there. I'll probably pull you back in like 12 minutes.